Today we're solving Leetcode 2976, minimum cost to convert string I. This problem looks like a string manipulation question, but the real test is whether you recognize it as a graph shortest path problem on characters, a very common interview trap. You're given two strings source and target of the same length, a list of allowed character transformations, original I, changed I at cost. You can apply any number of operations, even chaining transformations. Your goal: convert source into target with minimum total cost. If it's impossible, return -1. Let's walk through example 1. Input: source equals ABCD. Target equals ACB. We process the string one character at a time. At the first position, the character is A and it stays as A, so there is no cost. At the second position, the character changes from B to C. The direct conversion costs 5. At the third position, the character changes from C to B. There is no cheap direct conversion, so we use an indirect path. First convert C to E at a cost of 1, then convert E to B at a cost of 2. This makes the total cost for this position 3. At the fourth position, the character changes from D to E, which costs 20. Adding all the costs together, we get 5 plus 3 plus 20, for a total minimum cost of 28. This is the key realization. Each character is a node. Each conversion rule is a directed weighted edge. So the problem becomes, what is the minimum cost path from character X to character Y? And since we only have 26 lowercase letters, we can precompute all pairs' shortest paths. A brute force approach would be, try all transformation chains per character. Recompute paths repeatedly. Blow up with exponential combinations. Completely unnecessary. Step 1. Build a graph of characters. Nodes equals A to Z. Edge UV with weight cost I. If multiple edges exist, keep the minimum. Step 2. All pairs shortest path. Because only 26 nodes, we want minimum cost between any pair of characters. Use Floyd Warshall. Time complexity is trivial. 26 superscript 3 equals 17,576 operations. Step 3. Compute final answer. For each index I, convert source I, target I, add the precomputed shortest cost. If unreachable, return -1. We want to find the minimum total cost to convert one string into another string of the same length. Each character can be converted into another character with a given cost, and conversions can be chained through intermediate characters if that makes them cheaper. First, we assume that converting any character to any other character is extremely expensive by default. We then note that converting a character to itself always costs nothing. Next, we build a conversion table for all lowercase letters. For every given rule that converts one character into another with a certain cost, we record the cheapest known cost for that direct conversion. After setting up the direct conversions, we improve the table by allowing indirect conversions. For every possible intermediate character, we check whether converting from one character to another through that intermediate character is cheaper than the currently known cost. If it is, we update the cost. By the end of this process, we know the minimum possible cost to convert any character into any other character, whether directly or through a chain of conversions. Once all minimum conversion costs are known, we compute the total cost of converting the source string into the target string. We process the strings character by character. For each position, we look up the minimum cost to convert the source character into the target character. If at any position the conversion is impossible, we return -1 immediately. If all character conversions are possible, we add up their costs and return the final total. This value represents the minimum cost needed to transform the source string into the target string. Time complexity. The Floyd Warshall step runs on a fixed set of 26 characters, so its runtime is constant and does not grow with the input size. The final scan through the strings processes each character once, so it grows linearly with the length of the string. Overall, the time complexity is linear in the length of the input string. Time complexity is big O of n. Space complexity. The conversion table stores costs for all pairs of 26 characters. Since this size is fixed, the space usage is constant. Space complexity is big O of 26 square. Common mistakes and edge cases are forgetting multi-step transformations, running Dijkstra per character, overkill, not taking minimum cost for duplicate rules, assuming direct conversion must exist. Recap. Model characters as graph nodes. Pre-compute cheapest conversions. Apply result per character position. Interview tip. When constraints are small and fixed, pre-compute everything. It's often the cleanest solution. This is exactly